I think as the GIS industry in South Africa, we need to start fully embracing the AI revolution that we are starting to see across the world. I think that if we don't start embracing it, there will be other professionals from outside of our industry that will. And there is a chance that many of us as GIS professionals will be left behind. Now, as many of you know, AI already has the ability to automate all aspects that we are involved in as geospatial scientists, from data extraction to database development, to map production, data analysis, the creation of metadata, and utilizing that information to then contribute toward the development of policy and strategies. Let's not be naive about the power of AI in our industry, but we must be cautious about its application, knowing that it does not address all issues and that there will be a need for GIS professionals to validate and interpret the outputs, testing them against the theoretical frameworks that we know about, and to test them against what we know is the reality. So the focus of my presentation is going to be on giving you a little bit of background as to what is AI, potential role within the GIS industry, some of the case studies that we have been involved in, and some potential future trends of where AI is going to be utilized in our industry. So many of you will be aware that the AI started in around about the 1940s and 50s, and initially they were computational models that were developed to try and emulate the human brain. And what's fascinating about the human brain is that if one looks at all the sensory inputs that we have into the brain represents them as symbols, and it understands it as symbols and interprets it based on those particular symbols in terms of the behavior that it will then bring about in terms of our bodies. And if one thinks about it from that particular point of view, one then realizes that artificial intelligence is doing a very similar thing, and this is how it operates. Then in the 1980s, 90s, there was a breakthrough with the development of backward propagation algorithms that saw the more detailed use of neural networks in real-world applications. In the 2010s, deep learning became available, where more multi-layered networks were available, which consistently allowed the processing of more complex spatial data and imagery. And as you will know, in the 2020s and now is the introduction of large language models and AI agents. The advantage of what we are seeing now is that we can utilize natural language in combination with many of the AI models that are available to bring about spatial reasoning and to bring about an intuitive interaction with GIS and GIS analysis. So AI's role in the geospatial industry, I think a critical role is that it's bridging the gap between the complexity of geospatial data and its use. We know that from international research that only about 10% of the global population is able to do spatial problem solving, although in more recent years this might have changed as more and more people have been exposed to spatial data, such as through the use of Google Maps. Nevertheless, it is very difficult for most of the global population to utilize geospatial data, including data analysts and GIS software, to analyze it and to interpret the results. But with the introduction of large language models, this is becoming significantly easier and exposing our geospatial information more and more to a global population. So the challenges that we face in terms of geospatial data is the complexity. We deal with high dimensional data from multiple sources. The complexity of these multiple layers of data is that in many instances they are non-linear in fashion, and as a consequence, the ability to analyze them using normal methods becomes quite complicated. We also have a lot of unstructured data and textual data, and all of this data can be brought to bear in an AI solution, which gives it its incredible strength. So it is able to model nonlinear data. It is able to automate the processes, and it's able to bring all of these multiple sources into play to be able to analyze it and to identify the many hidden patterns that are available there. In most instances, the traditional methods can only do it in a univariate or a bivariate way, but with the introduction of artificial intelligence, it can be done in a multivariate way with data of different types and from different sources. So if one looks at some of the more common applications of AI in geospatial analysis, probably the one that many of us will know the best is the utilization of artificial neural networks to do classification of satellite imagery to identify land cover as an example. But by the integration of other layers of information and the use of artificial intelligence, one is then able to go even much further to do analysis of land cover and make predictions in terms of what the land uses of that land cover could be. And in addition to that, by the integration of these different layers, one is able to get a much higher level of accuracy in terms of the analysis. Some of the methods that you might not have come across is the use of self-organizing maps. It is a neural network that has been used to develop geodemographic segmentation. What it does do is that it looks at the population characteristics and human behavior and consumer behavior in combination, where it clusters information. So you've got a lot of inputs coming in. It makes sense of all of those inputs. It weights those particular inputs, and then it makes a prediction in terms of the categorizations or the lifestyle categorizations, as you see on the image on the right-hand side. I think that an area where more and more AI is being utilized in the geospatial industry is to look at object detection and extraction. And it's becoming stronger and stronger all the time as we are able to utilize symbols and features to identify information on imagery, to then be able to combine all of this information to extract roads, buildings, and other information from aerial photography. So the critical advantage of AI in the geospatial environment is that it can model nonlinear data, and it can integrate data from a multitude of sources for us to be able to better understand the pattern that we are seeing. I just want to talk about some of the case studies that we have been involved in. The first one is the work that we did at the Human Sciences Research Council many years ago, where we took the 2001 census data and using a coordinate self-organizing map, clustered the 2001 census data, utilizing a number of different variables that were available from the census at a granular level. So it would include the size of the population, household and individual income, the style of the house, the ownership, the number of people within that household, the levels of employment, the male to female sex ratios, population group, the age profiles of people living in the EAs, their home language, level of education, and also the type of area. And what we were able to do using artificial neural networks is to develop a geodemographic or a lifestyle segmentation and 20 different categories, which, utilizing other statistical methods such as hierarchical cluster analysis, we were able to determine that the 20 groupings are a good number that effectively described all the variance associated with the input data, which was the 2001 census. And we were able to create a number of different classifications. So, for example, there was a grouping called the highbrow. This would be high per capita income people living in suburban areas of South Africa. Jongens, which would be a younger populations with moderate income living in formal housing. A cluster such as the Eastern and Khosi, which would be people living in the rural areas, especially isiZulu speaking people, which generally had a lower access to services. And then the Mjondolas, which were densely populated informal settlements. And it's important to emphasize that the utilizing of these methods allows one to show that there are not only different types of informal settlements, but there are also different types of townships that occur throughout the whole of South Africa. And what is also important in the development of these sorts of databases is that there should never be the utilization of terminology that in any way discriminates one group of people from another. The importance is to understand that they exist and to understand their characteristics, because each of these different types of groupings have the insights to enable government to bring about target service delivery to them, for the changing of policies as an example. And then in addition to that, for commercial companies to look at the opportunities for the advertising and the development of services and products for these different communities across our country. More recently, and on a more regular basis, we have utilized neural networks to model and map the living standard measure or the socioeconomic measure of South Africa. Now, these particular proxy indicators have been used for many, many years as a mechanism by which to look at what's happening within the marketplace. But very importantly, they give us a longitudinal trend in terms of what is happening in terms of poverty and wealth within our country. And the artificial neural networks are ideally suited to be able to conduct the modeling and the mapping of the data. So we utilized the General Household Survey to model the mapper, but more recently, we've utilized the Marketing All Product Survey, which is the biggest consumer survey conducted in South Africa, where 20,000 households are interviewed on an annual basis. And the sample design is such that we can integrate the household survey data with secondary data sets, and then to utilize a general regression neural network to impute the data from the areas where interviews were conducted to all other areas in the country, which means that over 103,000 spatial enumeration areas, we have got data on what is the living standard measure and the socioeconomic measure at that particular level. And this information is consistently used even now by many companies to define who their target market is, but can be utilized, for example, by Eskom has to use living standard measures as their demand forecasting indicator in looking at the provision of electricity. So these data sets are invaluable, and artificial intelligence is one of the few mechanisms by which one can effectively accomplish what we are needing to do. And it allows us to do it on a fairly regular basis. We update this information on an annual basis. Just to show you that these methods can also be utilized outside of the South African context. For several years now, we have been mapping the concentration and distribution of micro, small, medium enterprises in a select set of countries in Africa. Again, in essence, what happened was that a survey was conducted in Malawi. We then integrated that data with about 14 different universally available geospatial data sets that cover the whole of the continent. And by creating a model between the survey data set and the universally available geospatial data sets, we were able to give an indication of the concentration and distribution of MSMEs across the whole of Malawi. What we were then able to do is to take that model and to apply it equally to South Africa, integrating other secondary data sets in order to make adjustments to the model. And the same thing was then done in Lesotho, Eswatini, and just more recently, Tanzania. And this information is utilized by organizations as a sampling frame to draw samples across these particular countries to go and do more detailed analysis of micro small enterprises, especially in terms of their financial access in the country. And this will continue into the future. And what we have found is that when doing these modelings, that the proximity of interviewed people to roads is a critical factor in defining the concentration and the character of small, medium enterprises, as is the nightlights, which is not only a cluster of where economic activity happens, but also is reflective of where people are residing. And one can bring into play terrain information, slope information, population data in order to bring about a modeling of this information. And how this is done is that we provide this integrated data set to a combination of machine learning algorithms. The machine learning algorithms then analyze the data from that analysis from the 14 different models. It then provides you with an indication as to which of the models is the most accurate in predicting the outcome, and that then is used in order to do the imputation of the data set. So let's just maybe look at some future horizons and emerging trends in terms of the application of AI in the geospatial industry. There is no doubt, and it's starting to happen, that spatial information will start to be used real time in terms of its use in making decisions, whether it be in terms of disaster management, traffic management. For example, in the Western Cape, AI agents are already being utilized in the traffic management services in the province in order to deploy traffic vehicles to particular areas where it is anticipated as the greatest need. And the AI agent is simply being talked to by operators in order for that to be accomplished, as well as to develop a smart city infrastructure. I see that in the future, already a lot of work has been done in the use of automated feature recognition in terms of different types of housing. There are complexities, especially, for example, in identifying the differences between informal settlements in dense areas. But with the utilization of artificial intelligence, not only will you be able to improve on the classification, but you'll also be able to potentially go to a higher resolution rather than a 10 centimeter or smaller resolution in order to be able to predict the concentration and types of dwellings at a local level, as well as to be able to do road extraction and the conducting of land use classification. Of course, in terms of twin cities and those sorts of things, neural networks are going to play a critical role in looking at defining things like, for example, predictive maintenance of buildings, of roads, where the urban growth is going to happen. Urban growth is not a linear process. It is a dynamic process which requires significant amounts of information in order for that to be identified. That is where artificial intelligence is going to be utilized more and more. We know that there are a lot of climatic models that are out there, but more and more artificial intelligence, especially with machine learning algorithms, is becoming integrated and improving the accuracy in terms of the predictions. And then again, in terms of demographics, we have been able to utilize artificial neural networks to update the population estimates for South Africa to 2024 levels at an EA level, utilizing these different multiple layers of information and neural networks to do that. I think that the complexity of the matter that we need to be looking at, and the world is already talking about, is the ethical aspects of the utilization of AI technologies in the geospatial industry, ensuring that the methods that are used are totally transparent and that there is a fairness in terms of the precision of the information. And I believe this is where GIS professionals are going to have to play more of an important role once they start to bring about a more effective integration of AI technologies into the geospatial industry in making sure that what is being done is ethical and true. Just to indicate to you that we are involved in developing an AI GeoNavigator. It will be developed on a database in the Republic of Ireland called GeoDirectory. It is considered the most sophisticated address database in the world by Google. It consists of 2.3 million addresses which are updated on a daily basis through the local post agency, and it has got an extensive amount of information. But the problem that you face is that there is a very small percentage of the population that can actually analyze this data because they do not have the GIS skill sets. So with the integration of large language models, more and more people will be able to analyze this data. And as a consequence, it will bring about a more sustainable and more profitable development of this particular product, whether it be in location of retail facilities, offices, distribution centers, or service facilities. The other area where there is a significant movement is in the development of AI swarms. A swarm is a combination of AI agents that work together with one another in conducting the analysis. And the swarms have largely been developed outside of the geospatial environment. And this is really going to be the cutting edge in terms of where AI is going to play its role in the geospatial industry, where you can bring these agents together to automate many, many different geospatial tasks, from the extraction of data, the analysis of that data, the production of maps, the visualization of the data, determining whether the data is metadata compliant. And all of this through the use of natural language models, the interrogation of the data set, and then also the creation of APIs. And that API then becomes available to GIS software, whether it be in the open or the commercial sectors of our country. So let me end by talking about the AI revolution in Africa. Many of you will know that the availability of information, geospatial information in Africa is very, very limited. But with the utilization of AI technologies and some of the universally available geospatial data sets, we believe that more and more data is going to become available on the African continent at a granular level, which is critically needed, not only in South Africa, but on the continent in order to bring about development. And in order for that to happen, the expertise of utilizing AI technologies in the geospatial industry will need to be developed. It will need to be at a granular level in order for effective insight to be provided in bringing about the development, and the importance of partnerships, working with government, businesses in the development of information such that targeted interventions can be implemented. Just as an example, we have recently modeled and mapped income distribution for Nigeria as well as Kenya. Generally speaking, this data is not available in the public domain. It's not available because it is too difficult to model utilizing normal methods, but the use of AI technologies or machine learning algorithms has enabled us to be able to model the data at a granular level, whether it be for infrastructure planning, economic development, supporting of micro, small, medium enterprises, looking at resource allocation to schools and health facilities, or the location of these facilities in a country, or the development of smart cities. It's a critical aspect. So in conclusion, the future of spatial intelligence will be powered not just by data, and AI technologies will power the development of data, but more and more this data is going to be utilized by these machines in order to learn more about what is happening in South Africa and on our continent.